Okay, we've been doing these regression estimates through this process of converting to z-scores. But there's another way that we can do this, and that is just by getting the equation for the regression line. We know that our estimates fall on this regression line, right? On a line called the regression line. Well, and if we get the equation for this line, then given any x, you could plug it into the equation and solve for y, right? So you might prefer to do that. So now you'll have two methods for doing these regression estimates. So think back to Algebra 1. What's the equation for a line? Is this the form you learned it in, y equals mx plus b, where m's the slope and b's the y-intercept? Does that sound familiar? Otherwise, I'll introduce other terminology that's more statistical language. Is this familiar? Okay, then let's just stick with this one. All right, so let's start with the slope. For the regression line, we know the slope is this. Remember this? Maybe not, but in case you forget, let me just remind you why that's the slope. So you have two lines here. You have two lines. This is the SD line, and this is the regression line. This is the line that has the perfect correlation. If every point was on this line, then all your z-scores would match up. And if you went over one standard deviation in the x direction, you'd go up a full standard deviation in the y direction to the point 1, 1. We know for the regression line, that's not what we do. For every standard deviation, let's say it was a z-score of 1, going in x has a z-score of 1, to get the z-score for y, we multiply by r, which brings us closer to the average. We don't go up a full standard deviation. We have a mixture of going up to a perfect correlation. If r was 1, or if r was 0, we just predict the average. And R basically tells us what that mixture is. The stronger R is, if R was 1, then we'd go all the way up. If you have a z-score of 1 in x, you'd have a z-score of 1 in y. If you had a z-score of 2 in x, you'd have a z-score of 2 in y. And every point would be on the standard deviation line. If R was 0, you'd have complete scatter here, and you would just, no matter what your z-score was, you just predict the average. So this really tells us the slope. The slope of the regression line is what? Just look at this. The slope of the regression line is equal to what? You can just see the picture. Is equal to what? First of all, it's rise over run. So if we run, that's just the easiest thing to do is to start at the point of average of 0 and go over one standard deviation in the x direction. Then, what is that rise? It's not a full standard deviation in the y direction. That would take us all the way up to there. It's not. You always multiply, you don't go so far. You always multiply by r. So that is the slope of the regression line. We already have that. By the way, if you forget the slope of the SD line, the slope of the SD line, the slope of the SD line is what? What is the slope of the SD line? If you went over one standard deviation in the x direction to a z-score of 1, to get to the SD line, you'd have to go a full standard deviation in the y direction. Okay? Now, so we know this. If you're in z-scores, it's so easy because the standard deviations in z-scores are 1. So if I converted everything to z-scores, the point of average would be 0, and the slope of the SD line would be 1, and this would be r, the slope of the regression line. But we're not usually in z-scores. Okay, so that's, any questions on this? By the way, what does r look like to you to be here? How can you determine what r is here? I say Look at this. I say R tells you what mixture you are between having no correlation, and your prediction just would be a horizontal line, and a perfect correlation. So you just have to think how far up. I'm just going to make a similar triangle just over here. So if this is 0 and this is 1, where does this line cross? Just mark it off. It's into tenths, let's say. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. What does this look like to you? 0.5, 0.1, 0.2, 0.3, 0.4, 0.5. Do you see what I'm doing? That would be 0.9. So R, in this case, in this picture, in this scatter plot, R is approximately 0.5. If R was 0.9, it would be way up here. It would intersect, it would be a very steep, much steeper line. If R was 0.1, it would be a much flatter line. All right, now it's time to do these problems, okay? Questions?
Do we always assume that the graph is to scale?
Do you always assume the graph is to scale? It doesn't matter if it's to scale. Do I always assume the graph? If I'm asking, do you mean?
Because you just ticked off 0.1, 0.2, 0.3,
Yeah.
If it's not to scale, that's not going to help us, right?
Yes, it will still help you because it's scaled relative to the SDs. It might not actually be to scale. Her question is very good. This might not be to scale. A lot of my graphs aren't to scale. But that it's scaled, it is that relationship between R, the regression line, and the standard deviation line will still be to scale, even if the rest of it isn't. Okay. So let's use that same data that we had last time and see if we can get the equation of the line. All right, so let's fill it in. We had 6.5 hours here, 8.5 drinks, 6.6 hours, and 10.7 drinks, and R was 0.75. So let's just make the same regression equations and see which way you prefer it, okay? So the very first thing that you want to do is what? What's the first thing that you want to do? You want to find the slope, okay? So first of all, just remember what the equation of a line looks like. We're estimating drinks, so which one should be Y? I mean, we want y equals mx plus b, right? But we're not given y and b, y and x. So which one's y? Is drinking y or x? Whatever you're estimating is y. So that has to be x. Whatever your variable you're predicting or estimating is always y. Okay, so this is drinks. So it's going to look like this. Drinks, the number of drinks is going to be equal to something, which will be the slope, something, that's m, we'll put our slope in there, times party, because that's x, times party, plus something. And what's that something going to be? Right in here. The y-intercept. So that we just have to fill in those two blanks. Now first find the slope. Okay, so you first find the slope, and we already remember what? How are you going to remember this? The slope is equal to what? If you, let's say it's an exam, you just completely forget, you completely blank. Slope. Do you think you could remember that it's going to be that you multiply by r, you know, to get from one z-score to another? The slope is going to be r, and then it's going to be a ratio of two standard deviations. 2 standard deviations. And do you think it's going to be y over x or x over y? Y over x, rise over run. If you went over 1 standard deviation in the x direction, you wouldn't go up a full standard deviation in the y. So that's your slope. Any questions on that? So you'll need to remember that, but it's not that hard to remember if you think logically about it. And r is given to you, 0.75. And now we just have to decide, is it going to be 6.6 over 10.7 or 10.7 over, those are 2 standard deviations. So which one is y? Is what, does everybody, it's what you're, it's going to be drinks per hour. Drinks is y. So put 10.7 on top, and then we have 6.6. And that's all you need to do. Any questions about that? And it might help. Sometimes in this case, it really helps if you put the labels in because it's drinks per hour. So it's going to tell you how many drinks, it's going to tell you how many drinks per hour. Okay, so drinks per hour. So let's do that on our calculator. And what do we get? We get 0.75 times, I hate this glare, 0.75 times what? 10.7 divided by what? Divided by 6.6. And we get 1.21590. How about just 1.2? Just 1.2? Okay, 1.2. All right, I'll tell you how much to round by. So what does that mean? That means for each extra hour of partying, you drink about 1.2 more drinks. That sounds about right. Now, we have to get this y-intercept, which is what? It's how much people, when partying is 0, when you don't party at all, or maybe before you go to the party at 0 hours, how many drinks you have. Okay? So far, what we have is 1.2 y. Now, to find b, the y-intercept, you can do this lots of different ways, but I think the easiest way is just to think about what you have. You have drinks so far equals 1.2 party hours plus something. And you can see when you have the drinks per hour, those cancel out. All right, so we're just trying to get this. Now, you know, this is an equation for a line, so it's true of every single point on the line. So if you know any point on the line, if you know any point on the line, if you know any point at all, you can plug this in and solve for b. Do we know any point on the line? What point always is on the line? The averages. So plug in point of averages. So plug in the average drinks here and the average party hours here, and we'll be done. Any questions on that? So if we plug in the average drinks, what is that? Look up here, and what do you plug in? So we have 8.5 drinks equals 1.2 times the average party hours, which is what? 6.5 plus b. And we just want to solve for b. That's all we have to do. The labels cancel. Any questions on that? So I don't have an extra line, so I'll just say, I'll subtract. So what is b? Should we subtract this from both sides? So should we subtract this from both sides? Okay, I'll do that. So I'll say 8.5 to get b, clear. I'll just say 8.5 minus what? 1.2 times 6.5. And I get 0.7. So that's my answer. So b is equal to 0.7. So I can put it right there. So B is equal to 0.7 drinks. I just subtracted that from both sides. You can check your work and make sure, you know, that when you put a 0.7 in here, it all adds up. All right, so now we have any questions so far? So let's write our regression equation. The number of drinks equals 1.2 times your number of party hours plus 0.7. Okay? That is your equation. Any questions on that? And now let's see what what did we do last time? Did we do 20? And we got 20, you know, we plugged in 20 on page 101, and we got 24.91, 25. Let's see if we get the same thing. So now for 20 hours per week, we'll say 1.2 times 20 plus 0.7. And we can do this one in our heads, right? So what do we get if we do that? You don't want to do it in your heads? Okay, clear. So we do 1.2 times 20, enter, plus 0.7. So it's 24.7. And last time, you know, we did some rounding here. Last time we got something very, very similar. We got what? We got 24.91. We were more careful here. We didn't do so much rounding. All right, so you can do it either way. Any questions on that? How well does the regression equation predict your own drinking behavior? What's your residual? Do you want to do that? Anybody want to volunteer to see how well the regression equation works on them? Anyone? No? You want to just move on? Okay. All right, you can just do that on your own, in privacy of your own house. Okay, so now we're going to go in the other direction. Now we're going to see that the regression of y on x and x on y aren't the same thing. We've already seen that before, but now we're going to see that they're different equations. So now find the regression equation for predicting. Oh, we'll go back to the mothers and sons examples, and we'll go back and forth. Okay, so let's do this one. So for predicting sun's height, so here sons are y. This is the same example we did in both directions, so let's look at this. But before we do this, do you mind, I'm just really curious how close we got to our own data, to what they said in the program. So let's just pull it up, and I just want to see what it got on the, here. So let's just go to survey 2, what was it? Spring 13. Survey 2. And let's just go to our scatter plus. I want to see if we got the same thing as what is up here. So if we first go to party and drink. And look at this regression equation. I don't know if you can see it, but it says that the number of drinks per week equals 1.223 party hours plus 4.764. So we did some rounding there, and the root mean square error is 0.7. We did some rounding there. And if you go the other way and flip it, let's see, we get drinks per week and party hours. Interesting. It's a different equation. Okay, so now let's go back to the overhead, and let's just finish this up, and I think we'll be done. So let's just, we're going to leave here early today. Okay, so let's look at this example. All right, so this is, you know, just to get you ready for the exam. If you do it now, you won't have to study so much. What if I say you had to find this regression equation? What would you do first? You'd first find the slope, right? you first might think, uh-oh, what is an equation for a line? Y equals mx plus b, because you already know that. And then you'd say, okay, sons are y. So you'd say son's height is equal to something times the mom's height plus something. And first you want to get the slope, and then you want to get your y-intercept. All right? So how would you get the slope? First you want to get the slope. See if you can write down the equation for it without looking back. See if you can do that. Actually, this is a pretty easy one. You could solve for this pretty easily. You can do this one in your head. Okay, so drawing a complete blank here, right? You're going to know it's something over something, right? Aren't you? I mean, first you're going to know r. Are you going to remember it's r times something? Can you remember that? And then it's the ratio of two standard deviations. And is it y over x or x over y? It's always y over x. So if you get this far, all you have to do is look up here. You're given 0.5 is r, and now you've decided that whatever you're predicting is y. So look for the standard deviation. Sons are y. So 3 over 2. It has to be. Does everybody see that? Does everybody see that? So that's 0.75. So you stick that right in here. How many people got that far? Now, what's our next step? Let's just write it out so you don't forget it. To find the y-intercept, you can do it lots of different ways. You don't have to follow it this way. I'm sure you can, you can do it other ways too. But I think the simplest way to remember it is to find the y-intercept, you just plug in the point of averages. That's all you have to do. You have this, you know now that sons are equal to 0.75 moms plus b. And you want to get b. So all you have to do is plug in that point of averages. So write it underneath. What's the average for sons? Just write it down. And what's the average for moms? Just put those numbers in. Just look up at the table and just read it correctly. Here's your averages for sons, for moms. For moms, what is it? So now all you have to do is get that B. So you want B standing alone here. So you just subtract this from both sides of the equation. You want B standing alone. So when you subtract this product, you get B, and now subtract it from here. So let's do that on our calculators, and we get what? 69. Ooh. All I'm doing is taking 69 right there. And what do I want to subtract? That. So it's minus 0.75 times what? What does that say? 65 times 65. And that'll be my answer. 20.25. So that's what B is. Okay? So we solved and we get B is 20.25. And we stick it right in there. That's our equation. Any questions on that? It's pretty easy. Now, if we want to use this equation to predict the height of a son whose mom is 69 inches, we'll just say how tall. Okay, So we'll say son is equal to 0.75 times the mom is 69 inches plus 20.25 and see what we get. See if we get 72 inches like we did last time. Did we do it? Did I do everything right? So let's just try it. So let's just do it. So you go 0.75 times 69 plus 20.25. We know we want 72 and we got it. Because we got it both the last, the other direction, the other way. We didn't do so much rounding because I made up these data to be nicer. And on our exam, I'll try to make the numbers work out better so you'll get the exact same thing whichever way you do it. You have questions? Questions? This is a multiplication sign. Okay, now I want you to try this one. You have some time. Work together and try this one. It's not going to be the same. Why is it not going to be the same? Because what are you predicting now? Mothers. So see if you can just follow the same thing and just do it. It will help you see. And just do C and D right now. I'll give you just a few minutes and then we'll go over it. And then we'll just leave and that'll be it. And then we'll be done with regression. And I'll post your homework pretty soon. If you have a question, just ask. Let's go back and make sure everybody gets this. And now mothers are Y. So what are we going to do? If mothers are Y, we're going to have mom's height equals something times the son's height plus something. All right, so we want that slope. And the formula is the same. It's r times the standard deviation of y over the standard deviation of x, which is 0.75. But what's changed? The y and x have changed. Now moms are y's. So instead of 3 over 2, what do you think I should put in here?
0.5.
Oh, shoot. Where did I get the 0.75? Was that from our last example? Yeah, 0.5. But now, instead of 3 over 2, what should I put in here? 2 over 3. So that's 1/3. Now we have 1/3, and we just need that. Does everybody agree? Everybody agree? So now, this was our first step. Our second step is, what are we going to do? We're going to plug in the point of averages. So can I just do it right here? What's the mom's average? 65 inches is equal to 1/3 times the sun's average plus b. And now I want to subtract. All I'm doing is subtracting from both sides. The 1/3 69 inches from this side, so b stands alone, so I have to subtract it from this side. And let's do that. So you just take your 65 inches, right here, 65, and you minus 1/3 of 69, which I know in my head is what? 23, right? Minus 23, and I get 42. Okay, so that is the answer. Right there is your equation. Any questions on that? And now, please don't leave yet. Please. You still have a lot of time. Don't leave. And now, what do we want to do? We want to see what happens when we put 72 in. So we have our equation. Moms equals 1/3 sons plus 42. And now when we put in 6 feet for the sons and add 42, we don't get 69. What do we get? 66 inches. That's how tall. So that's another way to show that the regression of y on x and x on y are not the same thing. Now let me just see what else we have to do here. That's it. And so we're getting out early today, and I'll post your homework right away.